Good day, learners. Welcome to the second week of the final term discussion. Last week, you have learned about the properties of electromagnetic wave and the properties of vacuum and optical medium. More so, the conditions for total internal reflection were also elaborated. This week, we are going to continue the properties and behaviors of light that are the same as the other waves. Now, it was mentioned in the prior discussion that the speed of light travels at a speed of 3 times 10 raised to 8 meters per second in vacuum. But when light travels from other transparent materials, it slows down. And this is what we call refraction. Refraction is the change in direction of a wave passing from one medium to another caused by its change in speed. Any transparent material is characterized by the index of refraction. It is a dimensionless constant obtained by dividing the speed of light in vacuum by the speed of light in that material. So in this equation, your n is the index of refraction, c refers to the speed of light, which is equal to 3 times 10 raised to 8 meters per second, and v is the speed of light in that material. We have here the indices of refraction, which are constant. For air, it is 1.0003. For vacuum, it's exactly 1. For air, which is also accepted as 1. For water, it's 1.33. For ethyl alcohol, 1.36. For oil, it's 1.46. Glass, 1.50. Polystyrene plastic, 1.59. Cubic zirconia, 2.18. Diamond, 2.41. And silicon is 3.50. Now, to fully understand the equation under the index of refraction, let us apply it in a specific problem. So we have the problem number 1. The speed of light in some glass is 65% of its speed in vacuum. Find the index of refraction. For problem number 1, we have a given speed of light, a relative speed of light which is equal to 1, and the ratio of the speed of light which is 65%. But of course, we have to express that percent into decimal point. Therefore, we have V is equal to 0.65. Now, we use the formula of index of refraction, which is N is equal to C over V. Substitute the given, C is equal to 1, divide it by 0.65, okay. 1 divided by 0.65, we now have 1.54 as the index of refraction. Okay, so the index of refraction for example number 1 is 1.54. Another problem under the index of refraction. Calculate the speed of light in diamond. What percent is this of the speed of light in vacuum? For the second problem, we need to calculate the speed of light in diamond and the percent of this speed of light in vacuum. So first thing to do is to write the given, but unfortunately I wasn't able to indicate the given. But we all know that the index of refraction is equal to 2.41 and the speed of light is 3 times 10 raised to 8 meters per second. In order for us to get the speed of light, we will use the formula N is equal to C over V. But since we are getting for the value of V, we manipulate this formula and derive with V is equal to C over N. Now substitute the given. We have for the speed of light, that's 3 times 10 raised to 8 meters per second. And for the value of n, it's 2.41. So 3 times 10 raised to 8 meters per second divided by 2.41 is equal to 1.24 times 10 raised to 8 meters per second. So the speed of light in diamond is 1.24 times 10 raised to 8 meters per second. Now, in order for us to get the percent of this in the speed of light in vacuum, we have to divide V over C. Okay, so we have percent is equal to V over C. So the value of V is 1.24 times 10 raised to 8 meters per second divided by 3 times 10 raised to 8 meters per second. And of course, we need to express it in percent. So we have to multiply it by 100. So we got 41.3%. I repeat, the speed of light in diamond is 1.24 times 10 raised to 8 meters per second. And the percent of this, of the speed of light in vacuum is 41.3%. The refraction of light is governed by a simple law. First is the law of refraction, which states that the normal line, the incident ray, and the refracted ray are all lie on the same plane. Second is the Snell's law, named after Dutch astronomer Wilbrod Snell, which states that the ratio of the sines of the angle of refraction and the angle of incidence is equal to the inverse of the ratio of the indices of refraction. We have the equation n1 sine theta 1 is equal to n2 sine theta 2. n1 refers to the incident ray, sine theta 1 refers to the angle of the incident ray, n2 refers to the refracted ray, and sine theta 2 refers to the angle of the refracted ray. Now, what is the relationship in this equation? This is inverse proportionality, meaning the ray that is in the denser medium is traveling slower and makes a smaller angle with the normal line, while the ray that is in the less dense medium is traveling faster and makes a bigger angle with the normal line. I repeat, the ray that is in the denser medium is traveling slower and makes a smaller angle with the normal line, while the ray that is less dense medium is traveling faster and makes a bigger angle with the normal line. Now let's have the problem number 3. Light is traveling through water and is incident upon a smooth salt crystal at an angle of 60 degrees with respect to the normal line. The indices of refraction of water and salt crystal are N water is equal to 1.33 and N crystal is equal to 1.54 respectively. Okay, so the given for the example number 3, we have the incident ray or the N water, which is equal to 1.33. For the refracted ray or the N crystal, that is 1.54. And for us to get the refracted angle, we will use the equation of the Snell's law, which is N1 sine theta 1 is equal to N2 sine theta 2. In order for us to get the refracted angle, we divide both sides by N2. Now we have N1 sine theta 1 divided by N2, is equal to n2 sine theta 2 divided by n2. Cancel similar quantities, resulting to sine theta 2 is equal to n1 sine theta 1 divided by n2. And now, since we are looking for the refracted angle, we now get the inverse sine of n1 sine theta 1 divided by n2. Okay, so this will be our formula in finding for the refracted angle. Substitute the given. We have theta crystal as your refracted angle is equal to the sine negative 1 of incident ray or n water sine angle or theta water divided by n crystal. Okay, so n water is equal to 1.33 sine the angle of water, which is 60 degrees, divided by the value of n crystal, which is 1.54. Now that is equal to 48.41 degrees. Okay, so the angle or the refracted angle of crystal is 48.41 degrees. For the problem number 4, refer to the figure given and answer the following. A. Calculate the index of refraction of the unknown material. And B. What is the speed of light within the unknown material? For number 4, we have, for letter A, we have to calculate the index of refraction of the unknown material. Now, as you can see in the figure given a while back, the refracted ray is the n water and the incident ray is the unknown material. So, in this example, we are looking for the n1. So our given for n water, it's 1.33. For the refracted angle, which is the theta water, is equal to 42 degrees. For the angle of the unknown material, it's 30 degrees. And of course, the index of refraction of the unknown material is still missing. Okay, so again, we will be using the formula of the Snell's law, which is n1 sine theta 1 is equal to n2 sine theta 2. But since we are looking for the index of refraction, therefore we will divide both sides by sine theta 1. Okay, so we have to cancel sine theta 1 and sine theta 1 here to obtain the value of n1. Okay, so the formula that we are going to use in this problem is n1 is equal to n2 sine theta 2 divided by sine theta 1. Okay. Next is to substitute the given. For n2, we have 1.33 sine 42 degrees divided by sine 30, and that is 1.78. So the index of refraction of the unknown material is 1.78. Okay, so for letter B, we are going to calculate the speed of light within the unknown material. And since we already know the value of the index of refraction of the unknown material, it will be easier for us to calculate the speed of the unknown material. So we will use the formula of the index of refraction, which is n is equal to c over v. Okay, derive this formula to have v is equal to c over n. Okay, so we all know that the value of the speed of light is equal to 3 times 10 raised to 8 meters per second, and the value of the index of refraction that we just calculated is 1.78. So 3 times 10 raised to 8 meters per second divided by 1.78 is equal to 1.69 times 10 raised to 8 meters per second. So, I repeat, the index of refraction of the unknown material is 1.78 and its speed of light is 1.69 times 10 raised to 8 meters per second. Let's proceed to the total internal reflection. This happens when the angle of incidence in a dense medium exceeds a critical value, and instead of light going through the interface, it reflects. In other words, the interface between the medium acts like a mirror. Equation of total internal reflection is given by theta c is equal to sine negative 1 multiplied to n2 divided by n1. Let's have a problem under the total internal reflection. Light strikes the boundary of a diamond facet with air at an angle of incidence equal to 20 degrees. Calculate the following: A. Angle of refraction, and B. Critical angle of diamond. Okay, so in this example, we assume that the angle of diamond is equal to 20 degrees and its index of refraction is 2.41 and that is constant. So we are looking for the refracted angle of air. Okay, so we will again use the formula of the Snell's law, which is n1 sine theta 1 is equal to n2 sine theta 2. And since we are looking for the angle, we have to divide both sides by the value of the incident ray. So since we have n1, okay, cancel n1 to n1 in order for us to get the sine theta 1. After getting the value of the sine theta 1, we have to get the inverse sine of n2 sine theta 2 divided by n1. So our formula in getting the refracted angle is sine negative 1 multiplied to n2 sine theta 2 divided by n1. Okay. After getting the formula, substitute the given. We have n2, which is 2.41 sine the angle of diamond, that is 20, divided by the index of refraction of air, that is 1. Okay, so our calculated value for the refracted angle is 55.51. Okay. Okay, so for letter B, we have to get the critical angle of diamond. And we all know that the value in getting the critical angle is theta is equal to sine negative 1 divided times 1 divided by n. Okay, so n here is the index of refraction of diamond. So we all know that the index of refraction of diamond is equal to 2.41. So we just need to substitute the value of n in the equation. So sine negative 1 times 1 divided by 2.41 is equal to 24.52 degrees. I repeat, the angle of refraction is equal to 55.51 and the critical angle of diamond is 24.52. For problem number 6, light is incident in sapphire and refracts into air. what is the critical angle of sapphire? And letter B, what is the angle of refraction when the angle of incidence is 30 degrees? For number 6, we have to compute for the critical angle of sapphire, and for letter B, we have to get the angle of refraction when the angle of incidence is 30 degrees. Okay, so let's have first the given. The index of refraction of sapphire is 1.77 and the index of refraction of air is equal to 1. Now we have here the given angle, which is 30 degrees. Now to calculate for the critical angle, we have the formula theta is equal to sine negative 1 times n2 divided by n1. Okay, so our n2 is the index of refraction of air. Just substitute the given, that is 1, and our n1 is the index of refraction of sapphire, which is 1.77. So sine negative 1 times 1 divided by 1.77 is equal to 34.40 degrees. To get the angle of refraction, we have to use the Snell's law equation, which is n1 sine theta 1 is equal to n2 sine theta 2. And we are looking for the angle of refraction. Therefore, we have to divide both sides by the value of n2. So cancel n2, n2. Okay, we have sine theta 2 is equal to n1 sine theta 1 divided by n2. And to get the refracted ray, we have the inverse sine times n1 sine theta 1 divided by n2. So the value of our n1 is 1.77 sine theta sine 30, which is given in the problem, divided by the refracted ray, which is equal to 1. So our refracted angle is equal to 62.25 degrees. Okay, I repeat, our critical angle is equal to 34.40 degrees and our refracted angle is equal to 62.25 degrees. One of the things Sir Isaac Newton was famous for was separating white light into different colors using a prism. White light enters the prism on one side at an angle and spreads out, revealing the colors of the rainbow. This phenomenon is called dispersion. So dispersion occurs when the index of refraction of medium is a function of wavelength. While polarization refers to the direction that a wave is oscillating. Now we have here a figure that shows a string vibrating up and down. This wave is already linearly polarized. Now we put two fences along the length of the string to represent the polarization process. In the first case, the wave goes freely through because the spaces between the rails are parallel to the axis of polarization of the string. So the rails are parallel to the axis of polarization. Okay, but in the second case, however, the second fence has been rotated to 90 degrees. Now it permits waves that are polarized along the horizontal, and since our wave is polarized along the vertical, it goes through the first fence but not in the second fence. Okay? When a linearly polarized light goes through a polarizer at an angle, the intensity of I of the transmitted light is I is equal to I naught cosine squared theta. I repeat, the equation under polarization is I is equal to I naught cosine squared theta. Let's have a problem under polarization. Light that is linearly polarized along the vertical has an intensity of 9 watts square meters. It goes through a polarizer that is at 30 degrees with respect to the x-axis. What is the intensity of light transmitted by the polarizer? For the last example, we have a given of N naught is equal to 9 watts per square meter and the angle 30 degrees. Now, for us to get the value of I, we will use the formula of Malus or the Malus equation, which is I is equal to I naught cosine squared theta. Now, in order for us to get the real angle, we have to deduct 30 degrees from 90 degrees to get the angle from the normal line. So 90 minus 30, that is equal to 60 degrees. So 60 degrees will be used in this solution. Okay, so 9 watts per square meter cosine squared 60. Okay, so before multiplying this given to 9 watts per square meter, we have to multiply for 60 degrees by 2 to get cosine 120. So cosine 120 is equal to negative 1 half. So 9 watts per square meter times negative 1 half is equal to negative 4.5 watts per square meter. But since there is no negative value, therefore we need to get, or we just need to get the absolute value, which is 4.5 watts per square meter. Now, before we end, I would just like to ask, how are we to determine when we must fall back or bend in a situation? Now, in my own opinion, we are all different. We handle pain and failures at varying levels, and these levels are just okay. It is just fine to fall back or retreat in situations we cannot possibly imagine that we would need to go through. And we can bend at will or change if we are ready to face those same challenges brought by support and passion. Okay, so always remember that it's not bad to give up, it's not bad to surrender, but be sure that when you are ready to fight or when you are ready to return, you are supported, you are determined, and you are compassionate to do whatever you are doing. So that's all, our dear learners. I hope that you learned something from the index of refraction down to polarization. And if you have queries, you are free to message your subject teachers. So that's all. God bless and keep safe.